This is AS Module 2, a paper from June 2010, and the question focuses on the topic of lenses. Figure 3.1 shows a converging lens and its focal points in the principal axes of the lens. The larger squares in the grid are 1 centimetre squares. So from here to here is a 1 centimetre square. Part 1 then. On figure 3.1, draw an upright arrow to represent an object at a suitable position on the principal axis of the lens so that a magnified and real image of the object may be formed. Draw an accurate ray diagram to show how the image of the object you inserted is formed and label this image IG. So to gain a magnified real image, our object must be placed between F and 2F, and you should ensure that whenever you're drawing these ray diagrams you have a sharp pencil with a very fine lead. Like my diagram, I'm using a marker here to make it more clear on the camera, but you should use as fine a pencil as you can. So beyond F, I'm drawing the small object. There are two rays we normally draw. The first one is a ray parallel to the principal axis. That then is converged through the principal focus. And the second ray, remembering always to put an arrow on, the second ray comes from the exact same point on the top of the object and passes through the optical centre of the lens undeviated. And again, put the arrows on, make sure that it's a ray. And the final bit asks us to draw in the image, and the image is located at the point where the two rays cross, and we must label that image IG. In this question there are 3 marks. There's 1 mark for each ray correctly drawn, and then there's a 3rd mark for the correct location of the image. Now the mark scheme also says that if you forget the arrows, you lose a mark. And you must ensure that you have it as accurate as you possibly can, using a fine lead in your pencil. Part 2. Then it says to make accurate measurements from your ray diagram. To verify the formula for magnification, M equals V over U. Indicate clearly the measurements you take, write down their values, and show how they're used in your verification of the formula. That's why it's so important to have an accurate diagram. Well, U is the object distance, and in this case we have it as 3 centimetres. So U equals 3 centimetres. If we label this as U on the diagram and write down our measurement clearly in the space below, U is equal to 3 centimetres. And then you can measure or identify on your diagram the image distance is V, and counting out your squares, this is 1, 2, 3, 4, 5, 6.8 centimetres. You can see that on mine I'm losing accuracy slightly because of the nib in this pen. So we can say that M is equal to V over U, which is 6.8 divided by 3, which gives us a magnification of 2.27. You could also, if you wish, use the method where you measure the object height and the image height, and in that case you could say M is equal to image height divided by object height. The actual mark scheme identifies the magnification as 2, so you can see that by using this pen I have lost accuracy of the magnification and the measurements. There are 5 marks for that. 1 mark for identifying each of the measurements that you took, both on the diagram and clearly in your working out space. A 3rd mark for the formula. The 4th mark for substituting correctly in and for the accuracy of your measurements and drawing. And then the 5th mark for the final answer.